In today's lecture of design of jigs and fixture, we are going to see some of the new terminologies related to that. Let's understand in today's lecture the different methods used for location. There are different methods used for location of a work. The locating arrangement should be decided after studying the type of work, type of operation, degree of accuracy required. Then, volume of mass production to be done also matters a lot. Different locating methods can be described as below. The first is flat locator. Now flat locators are used for location of flat machine surface of the component. Three different examples which can be served as a general principle of location are described here for flat locators. These examples are illustrated. Let's see one by one. In the diagram first you can see the workpiece is given in the undercut location of a flat jig and the locator is a flat fix, whereas a horizontal button is used in location by horizontal button type jig. Now over here you can see the corner is been provided specifically in order to arrest different types of chips that will be produced during machining. Now in the diagram number 2 you can see a horizontal button is provided in order to hold the workpiece onto the jig. Now the spacious arrangement gives ample of space in order to accumulate the chips produced during the machining. Whereas the third method gives a vertical button, that is location by vertical button type, and the workpiece is going to rest, so there will be ample space between the jig body and workpiece. Therefore the chips will not be fixed up or will not be temporarily hold in between the workpiece and jig body. These are some of the methods of locating using flat locators. A flat surface locator can be used as shown in first figure. In this case, undercut is provided at the bottom. Undercut is provided at the bottom where two perpendicular surfaces intersect each other. This is made for swab clearance or chip clearance. In the second diagram it shows flat-headed button type locator. Flat-headed button type locator. There is no need to make undercut for swab clearance. Button can adjust to decide location of the workpiece. Now for cylindrical locators, let's understand how it is going to be taken. Now this is the cylindrical locator. You can see the diagram, whereas workpiece is cylindrical in dimensions. The undercutting space is provided. Then the locators have been also added and that is given onto the work table. You can draw the same diagram in your notebook also. Let's understand the theory part. A cylindrical locator is used for locating components having drilled hole. The cylindrical component to be located is gripped by a cylindrical locator filled to the jig's body and inserted in the drilled hole of the component. The face of the jig's body around the locator is undercut to provide space for swab clearance. That means from this position the extra swab that is generated will be cleared over here. Let's move ahead. Conical locators. A conical locator is illustrated over here. You can see the drilled hole that is going to be drilled. Then the workpiece, conical locator that is supporting, and the work table. A conical locator is used for locating the workpieces having cylindrical hole in the workpiece. The workpiece is found located by supporting it over the conical locator inserted into the drilled hole of the workpiece. A conical locator is considered as superior as it has a capacity to accommodate a slight variation in the hole diameter of the component without affecting the accuracy of the location. Degree of freedom along z-axis can also be restrained by putting a template over the workpiece with the help of screws. Let us move. Jack pin locator. Jack pin locator is used for supporting rough workpieces from the button. That is shown in the diagram. You can see in the diagram a jack pin is given and adjustable nut is also provided. Height of the jack pin is adjustable to accommodate the workpieces having variation in their surface texture. So this is suitable method to accommodate the components which are rough and unmachined. Now many times in industry, the condition happens that surfaces provided may not be always on a smoother side. So, for such rough and unmachined components, this type of jack pin locators can be used easily. We will see. Drill bush locator. Now let us first understand the diagram. You can see the workpiece in a symmetrical but cylindrical condition and how the bush locator. Now my dear friends, you have to understand that whatever the things we are discussing over here are dealing with a jig. So jig has a prima function of holding the component, locating the component as well as guiding the tool. Remember these 3 points: holding the component, locating the component and guiding the tool. Over here the drill bush locator is illustrated in figure 4.7. It is used for holding and locating the cylindrical workpieces. The bush has conical opening for locating purpose and it is sometimes screwed on the jig's body for the adjustment of the height of the workpiece. Next, Vlocators. Already we have seen Vlocators in our lab, but today we are again going to see. Now the workpiece is given with a semicircular shape. A V-shaped locator will help in order to locate this. This is the locator body. You will see Vlocators. This is the quick and effective method. This is the quick and effective method of locating the workpiece with desired level of accuracy. This is used for locating the circular and semicircular type workpiece as shown over here. The main part of locating device is V-shaped block which is normally fixed to the jig. This locator can be of two types: fixed V-locator and adjustable V-locator. The fixed type locator is normally fixed on the jig and adjustable locator can be moved axially to provide proper grip of V-band to the workpiece. That means this V-band can be adjusted according to our dimensions. Let's move ahead. Now this is the serious part we have to deal during location as well as working of the jig, and that is a clamping. In order to restrain the workpiece completely, a clamping device is required in addition to locating device and jigs and fixture. A clamping device holds the workpiece securely in a jig or fixture against the forces applied over it during an operation. Clamping device should be incorporated into the fixture. Proper clamp in a fixture directly influences the accuracy and quality of the work done and production cycle time. Now, in exam, there will be a question related to this, and the question will be, what are the requirements of a good clamping device? And it will be asked mainly for 4 or 8 marks. Let's understand one by one. We are understanding the requirements of a good clamping device. It should be rigidly hold the workpiece. That it should hold the workpiece very rigidly. The workpiece being clamped should not be damaged due to application of clamping pressure by the clamping unit. The clamping pressure should be enough to overcome the operating pressure applied on the workpiece, as both pressure act on the workpiece in opposite directions. Clamping device should be capable to be unaffected by the vibrations generated during an operation. It should also be user friendly, like its clamping and releasing should be easy and less time consuming. Its maintenance should also be easy. Then, clamping pressure should be directed towards the support surfaces or support points to prevent undesired lifting of workpiece from its supports. Clamping faces should be hardened by proper treatments to minimize their wearing out. To handle the workpiece made of fragile material, the faces of clamping unit should be equipped with fiber pads to avoid any damage to the workpiece. So, these were the requirements associated with the clamping processes. Then we will see the different types of clamps. Different variety of clamps used with jigs and fixtures are classified into different categories as discussed below. First is a strap clamp. It is also called as edge clamp. This type clamping is done with the help of a lever pressure acting as a strap on the workpiece. Different types of strap clamps are discussed below. First is a heel clamp. You can see the diagram of a heel clamp. The simple form of a heel clamp is shown over here. Rotation of the clamp in clockwise direction is prevented and it is allowed in anti-clockwise direction. For releasing the workpiece, the clamping nut is unscrewed. The free movement in anti-clockwise direction takes place before unsecuring the nut to release the workpiece. That means over here the lever will be putting pressure onto the workpiece, and that lever will be tightened, untightened using this nut bolt arrangement system. So this is all a heel clamp. Next is a bridge clamp. The bridge clamp is shown in the diagram. You can see it is somewhat related with the cantilever beam you have studied in the strength of material as well as in the engineering mechanics. The bridge clamp is illustrated in figure. It applies more clamping pressure as compared to heel clamp. Now the pressure will be exerted more, but due care has to be taken that there should not be any marking of the clamp onto the workpiece if it is very polished or it is very machined. The clamping pressure experienced by the workpiece depends on the distance x and y marked in the figure. To release the workpiece, the nut named as clamping nut is unscrewed. The spring lifts the lever to release the workpiece. Next, edge clamp or side clamp. A side clamp is also known as edge clamp. In this case, the surface to be machined is always clamped above the clamping device. This clamping device is recommended for fixed length workpieces. The clamping device is illustrated. Releasing and clamping of the workpiece can be accomplished by unscrewing and screwing of the clamping nut respectively. You can see the diagram, the workpiece and the edge clamp. The clamping nut will untight. The spring will provide sufficient rigidity pressure and the stud is provided at the end. Therefore, it will embark work pressure onto the workpiece. But a due care has to be taken that workpiece will not be tempered, workpiece will not having any marking system on the due to the clamping pressure. Next is a screw clamp. The screw clamp is illustrated in figure. It is also known as clamp screw. This clamping apply pressure directly on the side faces of the workpieces. There is a floating pad at their end to serve the following purposes. First, it prevents displacement of workpiece and slip. Second, it prevents denting of clamping area of the workpiece. Third, the available cushion prevents deflection of the screw. Now, in addition to the above, there are some disadvantages associated with this method. The clamping pressure largely depends on the workpiece. It varies from one workpiece to other. It is more time consuming and more efforts are required. Therefore, you can see the screw clamp or clamping screw that is acting pressure with the help of floating pad on the workpiece. Next, latch clamp. Now already you have used the word latch in your door mechanism. How the latch gives a fit, that is a tight fit is obtained in between the two bodies. That is a small lever from the latch mechanism proceeds and it locks, unlocks dependent on the necessity. Therefore, latch clamps are used to clamp the workpiece. The clamping system is normally locked with the help of a latch provided. To unload the workpiece, the tail end of the latch is pushed that causes the leaf to swing open, so releasing the workpiece. Here, time consumed in loading and unloading is very less as no screw is tightened, but clamping pressure is not so high as in other clamping devices. Life of this type of clamping device is small. Next, equalizing clamps. Equalizing clamp is illustrated in figure 4.13. It is recommended to apply equal pressure on the two faces of the work. The pressure applied can be varied by tightening or loosening the screw provided for the purpose. You can see equalizing clamp. Now, as the name indicates equalizing clamp, it is to be considered that there will be equal pressure departed over here. Next, light duty clamps, that is power driven clamping, are used manually because small power is required to operate this clamp. Hand clamping leads to application of variable pressure, operator's fatigue, and more time is consumed. The power driven clamping overcomes the above mentioned problem of hand clamping. Power clamps are operated on the base of hydraulic or pneumatic powers. Power clamps are high pressure clamping. These are quick acting, easily controllable, reliable, as well as less time consuming. Now, jigs along with fixtures are specially designated machine parts which can be manufactured by following methods. How jigs are manufactured, let's understand. By machining, by forging, by casting, and by a complicated method. Now these jigs are fabricated in different pieces and joined together using a welding method. Normally, jigs are made of hardened steel which are wear resistant, corrosion resistant, and thermally insensitive. Their dimensional accuracy directly influences the accuracy of performance of the operations where these are used. Different types of jigs. Now let us understand what are the different types of jig. But dear friends, dependent on the operations, you can understand what type of methodology in the mass production is to be used. For example, drilling jig. Now the condition for drilling jig is as it is provided. A drill bit has to be guided and it has to be given the order that how much depth it has to cover. Therefore, as per the definition of jig, it is clear that jig will hold the workpiece, it will locate the workpiece, it will clamp the workpiece, as well as it will guide the drill bit or drill tool to work onto the workpiece. Therefore, drilling jig are used for large number of operations. That is, different types of drilling jig that are used are template jig. This is a simple plate of metal or wood which carries correct locations of the holes to be made in the workpiece. Size of the template jig should be same as that of the workpiece. It is overlap with the workpiece and drilling is done quickly. Use of this jig avoids marking operations completely. That means it is very easy to handle template jig. Now the plate type jig. If the work is to be done on very large scale, an improvement can be made into the template jig, that is a plate type jig. This uses a plate having drill, pushes and suitable means to hold and locate the works that it can be clamped to the plate and holds drill directly through the bushes in correct positions. Next is a open type jig. You can see in the diagram. In this jig, the top is kept open and workpiece is placed on the base of the jig and a drill plate. Carrying the drill bushes is placed on the top to guide the tool. After the operation is over, the drill plate is removed and workpiece is replaced. And this means a number of operations or number of workpieces can be done simultaneously. You can draw the diagram as per your requirement. These are the locating pegs used and these are the drill bushes that works on the workpiece at a required position. The workpiece is also held very tightly in between that. Now, swinging leaf type jig. This type of jig carries a leaf or plate arranged at the top or one side which is capable of swinging about a fulcrum. It is normally the drill plate itself which is pivoted about a point at its one end. A swinging leaf type jig is shown in the figure. The work is loaded and unloaded with the help of swinging bolt. Now you can see the workpiece. It has been locked using a swinging leaf, then it is a knurl nut and it is a belt. A box type jig, its construction is like a box and it is used for the components having irregular shape and to be operated at different places. This type of jig provides rigid support so machining on the various places of workpiece become comfortable. Solid type jig, this is also used for drilling holes in articles of simple shape and relatively smaller sizes. This is made of standard section of rolled steel. Pot type, this jig is used for drilling holes in hollow cylindrical components having smaller size. Here, the body of the jig is like a pot that is used to accommodate the workpiece comfortably. Location on the inside surface of the component is provided by the clamp projecting from the bush plate located over the top of the workpiece. Index jig. This type of jig is equipped with the facility of indexing which creates positional division of the workpiece suitably. This jig is used for quick drilling of equidistant hole on the circular surface of the workpiece. By means of indexing device, a hole is drilled then. The workpiece is moved. Multi-station jigs. These jigs are designed for multi-spindle machine where many operations can be performed simultaneously. Each spindle of the machine carries a different tool to perform a different operation. Tools and spindles are arranged in the sequence in which operations are to be performed. Universal jig, as the name indicates, the name universal jig are meant to do large number of operations. These may have replaceable elements onto them. Selection and mounting of an element depends on the type of operations to be performed. Fixtures. Different types of fixtures used to hold the workpieces properly to carry out the operations. They are turning fixtures, milling fixtures, fixture for grinding, fixture for broaching, boring, tapping, welding, assembling, etc. So these are the different types of fixtures we are going to cover in the next lecture. You can see the diagram of the fixture that holds the workpiece, and remember, fixture is not going to what? It has the special condition that it will hold the workpiece, it will locate the workpiece, it will clamp the workpiece, but it will not guide the tool to work onto the workpiece. So we will discuss the same series of things in the upcoming lectures. Till then, thank you.